everyone and welcome back to my channel R&M Labgona. Do you remember the package I received from Steve? The one we unboxed together in the last video? Well, today I finally decided to get to work on that material to repair a few items that have become essential here in the lab. I wanted to dedicate this video to hardware recovery because we often throw away objects that still have a lot to offer. Together, we will see if these components are actually fixable and how we can give them a second life. This is only a small part of the package contents, but it's the most urgent for me. I need reliable tools to test the components I repair every day and to improve my workstation. Specifically, my goal today is to fix these two cell phone chargers. It might seem like a simple job, but since they both have two USB ports, they're pure gold to me. They allow me to power multiple devices at once without taking up too many outlets on my bench. One of these, for example, will be used permanently to power the special characters keypad I built a few videos ago. If you remember correctly, that project is helping me a lot with writing Arduino code, making everything much faster. If you missed that video, don't worry, I'll leave the link right down in the description. Additionally, with the second USB port free, I can keep the Bluetooth speaker powered on, which I use to monitor audio while editing videos or to listen to some music while I work. The second charger, once repaired, will become my standard task power supply for all the new prototypes that cross my bench. Let's get straight to work and see what's wrong inside. As you've just seen in the video, repairing these devices was fortunately very straightforward, but it allowed us to take a closer look at some common issues. The first charger had a classic fault. It had a visibly bulging electrolytic capacitor. Due to this faulty component, one of the two USB ports failed to deliver power, leaving only one port functional. To fix the problem, I dug through the box of components Steve sent me. If you remember correctly, that package was full of interesting spare parts. I found a compatible capacitor and replaced it immediately, restoring full functionality to both ports. As for the second charger, the problem was mechanical. One of the USB ports had a bent internal contact that either caused a short circuit or simply failed to connect. In this case, I decided to perform a radical transplant. I removed the entire double USB port and replaced it with one salvaged from an old computer motherboard. As you might have noticed, this new port is slightly longer than the original one, which forced me to slightly modify the plastic housing to fit it correctly. I'll admit, aesthetically, it's not the best looking, and it might not be the ideal repair to return to a customer. However, for my lab use, it's perfect. In fact, I'll tell you more, the port I installed is much more robust than the original and will hold up much better to the constant plugging and unplugging we do during testing. For my workbench, it's an absolutely winning solution. Now, let's move on to another interesting piece, a 4-port USB hub that has seen better days. As you can see, the original cable was cut clean off, but the real damage is on the board itself. Someone clearly attempted a makeshift repair using a soldering iron that was way too large, ending up overheating and damaging the circuit board traces. My goal now is to restore the main connections. However, I don't need this hub for data transfer. I'm only interested in using it as a power distributor for my workbench. For this reason, I will focus only on restoring the two power pads, the positive and the negative, while completely bypassing the rest of the data circuitry, which is already compromised. To give this hub a new lease on life, I'll be using some high-quality salvaged material. If you remember, Steve's famous box contained several cell phone charging cables, specifically the magnetic type. After testing them, I realized the issue was only in the external magnetic connectors, while the cable itself is still perfect. So, I've decided to cut off the magnetic connection part and reuse the cable. These cables are fantastic. They have a generous internal gauge and are silicone coated, making them extremely flexible yet very durable. They are truly high quality wires, great not only for powering this hub but also for keeping in stock for future projects and repairs where a flexible and reliable conductor is needed. Let's get to soldering and bring these 4 ports back to life. The USB hub has also been successfully repaired. As I mentioned before, the goal was to turn it into a solid and reliable power distributor. Thanks to the salvage cable I used, which has a very generous wire gauge, I no longer face voltage drop issues even when using all 4 ports simultaneously. This hub will have a very important task. It will power the extra cooling fans I built for my laptop. Since my computer is under a constant workload for video editing and stays on almost all the time, it tends to get quite hot. To solve this, I repurpose cooling fans from some broken laptops, and with this help I can power them at full capacity without any risk of cable overheating. But that's not all. Look at this leftover piece of cable. Nothing goes to waste here. By removing the outer fabric sleeve and the protective jacket, we can recover the 4 internal wires. What's interesting is that they come in 2 different gauges. The 2 power wires are thicker, while the data wires are thinner. Both are made of excellent material, high in copper content and very flexible. These wires are absolutely ideal for precision connections in our projects with Arduino, ESP-32 or any other electronic prototyping work that requires reliability. Since there are quite a few of these USB cables in Steve's box, I decided to use one more to create a fundamental tool, a test cable for quick checks on circuits and components. At the end, I've attached 2 small alligator clips specifically designed for electronics. This way, I can instantly connect any component or module I need to test. Having 5 volts always ready to go, simply by clipping on 2 alligator clips, is extremely convenient. It might seem like a minor thing or even a waste of time, but I can assure you that in daily practice, it's one of the tools you'll use the most. It's an incredibly easy solution to build, practically at 0 cost, but it will save you a lot of time during prototyping. When you're working on a project and want to quickly verify if a component works without having to set everything up on a breadboard, this cable becomes truly indispensable. It's like a little Swiss Army knife for every electronics enthusiast. While I was filming this video, a little unexpected thing happened. The bathroom light bulb burned out. Since I didn't have a spare one at home, I decided to fix it on the spot. As you know, modern LED bulbs can be repaired quite easily if you know what to look for. Failures in these types of bulbs are usually one of 2 things. First involves the individual LEDs. Often, it only takes one burnt out chip to prevent the entire bulb from lighting up. This happens because the LEDs are wired in series. When one fails, the circuit opens and the current stops flowing. There are 2 ways to fix this. The proper professional way is to desolder and replace the burnt out components with new ones. The second way, which is much faster but technically less ideal, is to remove the faulty LED and make a small solder bridge to close the circuit. This gets the bulb working again, although the remaining components will handle a slightly higher voltage. The other classic issue, which we already saw today while fixing the charger, involves the electrolytic capacitors. They often bulge due to heat, failing to stabilize the voltage. In that case, simply replacing the capacitor with one of the same capacity and voltage rating solves the problem. This repair wasn't planned for today's video, but since I urgently needed the light back on, I decided to include it. I hope this little detail proves useful to some of you. That's all for today's video. I truly hope you found it helpful and that it gave you some good ideas on how to tackle small home repairs and, most importantly, how to salvage valuable materials for our future projects. We've seen that with a little patience and the right parts, many items destined for the trash can be brought back to life. If you enjoyed this video and like this kind of content, don't forget to give it a big thumbs up and leave a comment below. Let me know if you've salvaged any interesting components lately. If you haven't already, please subscribe to the channel and hit the notification bell so you don't miss our next lab experiments. And, of course, share this video with your friends who are into electronics and DIY. Thank you so much for watching. I truly appreciate your support. I'll see you in the next video. Bye for now from R and M Lab Gona.